Welcome to part 3. This is on igneous rocks. Igneous rocks is one of my favorite types. It literally translates into fire rock, so it's pretty awesome. And it gives you a clue as to where they come from. So igneous rocks are basically rocks that are formed from cooling magma or cooling lava. Now, what's the difference between magma and lava? Well, magma is what we call the melted rock that's underneath the crust. So all the layers underneath the earth crust, those are considered to be magma. More or less, and magma that has managed to escape through the surface somehow, that then is considered to be called lava. Anything that cools down from those two types will be considered to be an igneous rock because they're formed from the fires of, I think that's the idea. Right, so with those two scenarios, cooling above ground or cooling underground can dramatically change the properties of the rocks. So we have different categories for them. We call them extrusive rocks when they come out through the surface and cool down rapidly. And we've got intrusive rocks which stay underneath the surface relatively and they cool down much more slowly. Let's talk about what the properties are. So if it's spewed out of the earth very rapidly, so the magma then turns to lava, then it's cooled rapidly in the air, that means that all the atoms that make up crystals or the minerals inside, they don't have enough time to sort themselves out in a nice, neat arrangement to make a crystal. You'll often find lots of little tiny crystals, so tiny you actually need to see microscopes to actually find them. They're very tiny, you can't see them. And that can have dramatic impacts on the structure. If you've got lots of tiny crystal grains or stuff like that that are interlocked, it tends to make a material that's very hard. Sometimes they tend to be very brittle, so hardness and brittleness usually go hand in hand. Intrusive igneous rocks tend to be the opposite case, where they cool down slowly. Those atoms have more than enough time to sort themselves out to pack nice and neatly in these rows to make a large crystal. So intrusive igneous rocks usually have the large minerals, the large crystals, so large that you can actually physically see these grains of crystals inside the rock. And this is where you see those, stores that you have like crystal gems that you can buy. Those are formed under those conditions because they are huge pieces of crystals. And when they have large crystals, they tend to be quite tough. A tough material and large crystal size go hand in hand. That means toughness is when something can take a lot of impact or shock before it breaks. So we find that same sort of scenario happening in steels and metals. If they are cooled slowly, then you tend to restore the toughness because all the atoms can pack nice and neatly in one giant aggregate, one giant arrangement of atoms, a crystal. So those are two types. Another thing that I'd like to add is that extrusive rocks can sometimes have holes in them. I think you've seen some stones like pumice stone if you've ever been near the beach. It has lots of holes in it and it's very, very lightweight. But why do they sometimes form with holes? Well, magma, when it's underneath the earth, can have lots of different things inside of it. One of those things can actually be gas. So if you've got a collection of gases dissolved in this really liquid type of rock, and when it makes its way to the surface, there's less and less pressure. Just in the same way, if you go to the bottom of the swimming pool, it's like lots of pressure. You can feel it on your eardrums, and you make your way to the surface, there's a lot less pressure. Same sort of thing with like a soft drink bottle. Whenever you open it for the first time, you see the bubbles rushing out to the top. That's exactly what's happening to magma as it makes its way to the surface. It makes its way to the surface, and all those gas bubbles that were dissolved come out. And they start bubbling out violently, just in the same way as when you undo the drink bottle. When they bubble out and the magma or lava cools rapidly, you can have these air pockets where those gases basically expanded inside. And so some rocks can have a lot of those pores and really large vacancies inside. Another cool thing is that if that rock then gets pushed underground again, other minerals in liquid form can seep into those vacancies and crystallize there as they cool down. So you can have some rocks which have other minerals within it. It's very cool. So every one of those pores, you would find sometimes little gem-like stones inside of them. Anyway, that's enough for igneous rocks. Next, we're going to talk about weathering, and we're going to talk about erosion because that's important to know before we get to sedimentary rocks.